Language is all around us. We use languages to explain and inform each other. We use languages to debate and to discuss. We use languages to analyze and study all kinds of problems in the world. And we use languages, of course, also to preserve our knowledge that we have collected throughout the years. In the digital age we live in, this also implies that language technology is also around us all the time. Technology is dictating our daily life, is providing tools behind the scenes that decide what kind of information we get and how we can organize our work in the age of information overflow. Recent years has been seen significant improvements that make language technology visible in many real-world applications. And we maybe sometimes don't think about all the applications around us and that we use in our daily life. So what is language technology and natural language processing? In a nutshell, language technology is concerned with the creation of computational models that can understand and generate human languages, giving rise to two subfields of natural language understanding and natural language generation. Both of them are naturally connected and refer to the basic questions that we ask about human communication and human-computer interaction. Language technology in this sense comes with two different sides: an academic side that studies communication and how languages are really used, and the applied side that focuses on development of practical tools. In the field, we are mostly concerned with the question about how to create appropriate language models and how to evaluate them. Many approaches use pipeline or modular setups, as you can see in this picture here. But so-called end-to-end approaches gain increasing popularity. There are many ways of building NLP models that can be implemented explicitly based on expert knowledge, but a more common trend is to rely on language data and machine learning techniques that pick up information from pure data and annotation provided by humans. Evaluation can be divided in two different approaches: intrinsic evaluation, that looks at the internal structures of the models that are created, and extrinsic evaluation that measures the success in so-called downstream applications, such as information retrieval, question answering, or machine translation. For all of this, language technology draws on a number of other disciplines, including general linguistics, computer science, cognitive science, and research in general artificial intelligence. In this course, of course, the main question is probably, what is in there for digital humanities and the social sciences? You probably know the answer already, but let's give one example from a practical collaboration between language technology and digital humanities. In a recent project, people looked at large bodies of textual data to study the connection between gender and certain professions in historical times. This work is tedious, and documents don't actually mention the professions of people explicitly in the text, but instead it becomes visible first when looking at the activities they perform, expressed by verbs and activities in the sentences that you have to study. Hence, it is necessary to find the predicate structure of sentences to identify the verbs describing an action or activity. So now language technology can come into the picture, as technology can provide the essential tools that can help to process large volumes of text, to mark and rank candidates to be studied in more depth, in order to support an analysis with a good coverage and sufficient empirical support. As such, the typical NLP pipeline provides many of those tools that accelerate such kind of research. And of course, in this case, this is just one of the practical examples where you can see the benefit of language technology. So to conclude, I just want to mention once again that NLP models and tools provide essential building blocks for many downstream applications. Some of them you can see here in this picture. Research in language technology as such is then fundamental in order to advance in many of the related fields, including digital humanities and computational social sciences. Thank you for your attention.